All right, we're going to go through the second page of the alpha carbon reactions on the aldol reaction. So I'm going to go through this page with you, and then what I would like you to do before we're back in classes again, whenever that may be, is to try some of the problems on the top of page 3 and even these intramolecular examples on page 3. So page 3 is a practice page for you to do. I'd like you to get to the point where you've filled in these notes and you can try those on that practice page. All right, the aldol reaction is named for the type of product that forms. It was first done where there was an aldehyde and an alcohol formed, so there's your ol, there's your aldol. It'll also work when there's a ketone product formed. So here's the first aldol reactions that were done, have both an aldehyde piece and an alcohol piece. There's an alpha carbon in the middle, and since on the beta position, beta to the carbonyl, there's an OH group. The product types are called beta-hydroxy aldehydes or beta-hydroxy ketones if this was an R group here. All right, so how does it work? We're going to go ahead and deprotonate the alpha position with hydroxide OH. That makes an enolate, which has essentially a nucleophilic carbon atom. Right, so it's electron rich, right? And that can react with a carbonyl from the same molecule. If it does, it's a self-aldol, or another molecule, and then it's called a crossed or mixed aldol. And when it reacts at this carbon here, and it would do so because that's a delta plus carbon, just because of bond polarity, it stitches together and forms a carbon-carbon bond, right? So if we went through and tagged, here's the carbon you formed an enolate out of right there, and then your carbon you attacked right here. And the new bond formed, obviously, is right between them. So the power of these aldol reactions and any other reactions we're going to do in this chapter is that there's a new CC bond formed, and that's how you can make bigger molecules out of smaller ones, right? So here you've just got a 2-carbon piece. Your product will be a 4-carbon piece after protonation to get your neutral beta-hydroxyaldehyde. Okay. Sometimes generically we could just call these beta-hydroxycarbonyl compounds. All right, so we're going to practice on these and talk about once they form a subsequent step that is really likely to occur. So here's the product from above. There's your beta-hydroxycarbonyl. And it just so happens if we form an alkene between the alpha and beta positions, it would be what's called unsaturated. That just simply means there's an alkene there, or a C double bond C. The reason this happens so readily is we have a conjugated system, right? And these conjugated systems are very stable. When you have alternating double, single, double bonds, that's called a conjugated system or conjugated molecule. And those are very stable. So what happens? It's essentially a dehydration reaction, and we'll go ahead and we'll go through and do this with hydroxide, which is the one that seemed like people struggled with a little bit. So there's a couple H's here, I'll just draw in one. Dehydrations in acid can also occur, right? But it was the dehydration in base that some of you said was a little confusing. We can pull off this proton, because it's still an alpha proton, it's acidic, swing these electrons up, they sit right here, and then hydroxide can act as a leaving group. And the only reason you can have an OH as a leaving group is because of the stable product. So the product stability is sometimes called the driving force of the reaction, what forces the reaction to occur, right? So this conjugated system is why we get this elimination reaction here to form an alkene. So an example of an aldol with dehydration is you might take this molecule here, acetophenone, and it has obviously acidic alpha H's. It could react with itself to form this beta-hydroxy ketone. Right? Here's your alpha position, there's your beta position, and then that can dehydrate to the conjugated. So these are sometimes called alpha-beta unsaturated carbonyl compounds. Right? And the key to them essentially is that they're conjugated. And this one's actually very highly conjugated because it's conjugated through the aromatic rings as well. So the base would pull off any of those alpha H's. we'll just go ahead and call this phenyl ring, just as an abbreviation. So you got a pH, and then your CH2 from your enolate, right, that you just formed. And since this is going to be another example of a self-aldol, this is going to attack another molecule of itself. So we'll just go ahead and we'll write pH again just for short. CH3. So this is how the two molecules link together, right? You just formed that bond. And then after a protonation step, initially you have an O- and it gets protonated to the OH. This is what you formed. The dehydration would follow the mechanism exactly as above. So you could draw that in again if you wanted to. It'll be a little crowded if I draw it in here, but there's the alpha H that hydroxide would remove. Let's see if we can't get it. So there's that removal of that H, that swings up, and that leaves. And there's your dehydration reaction. Alright, so I'd like you to try the one on the bottom of this page on your own, right here. Sorry, a little crooked. So it's a self-aldol. First form your beta-hydroxy ketone. Label your alpha-beta positions. That's real useful to do because it tells you where you're going to be forming your C double bond C after you dehydrate, right? Dehydration means loss of water. Here's the water that you're forming right there. Sometimes it's just written as this, minus H2O. So go ahead and do this one. You should be able to kick through that now. Then on the next page, instead of a self-aldol, I have an example of a crossed aldol. Here's your acidic H you're going to remove, attack that carbon. Go ahead and keep going and do that. Should be able to figure out, the rest of these, what's going on with them as well. So give them all a try, and I'll write up some answers, and we'll be starting with those in lecture next time we're all together, whenever that may be. All right? Happy snow day.